Hello, everybody. Good evening. Thank you for joining on this Thursday evening. The week is just flying by. I'm Alex Harper. I am the Education and Outreach Coordinator. And as one of the things that I like to do for Red Rock Audubon is add a diverse array of educational programs from different types of people studying different things related to birds, habitat, climate, policy, and so on. And so last summer, I had the chance to see my friend Alex give this presentation up in Alaska, where climate change is definitely pretty noticeable in ways that are a little bit different from here, although there is some overlap. And Alex, despite his busy schedule, agreed to give us this presentation via Zoom. He's tuning in from San Diego, California. Just moved over to that area of the world from the Pacific Northwest. So he's kind of a neighbor of ours, only 5, 6 hours away, depending on traffic in Southern California, which who knows what that can be like. Super unpredictable. Usually not that great. So I'm going to hand it over to Alex. Alex is going to chime in. We are recording. This will be up on YouTube and will live forever on the internet so that we can continue to share this with other members and our partners. So, Alex, the stage is yours.
Great. Well, thank you. If it helps, I was born in Reno, and for the first few years of my life, I still have family there, and then moved to Portland when we were four. But welcome. My name is Alex Rubenstein. This is a Birds in Our Changing World presentation. I am really passionate about birds, and I've been working up in Alaska for the last 4 years and have become a lot more passionate and interested in the ways that climate change and global change and human impacts are affecting bird habitat and reproductive health and status around the US, around the world. I started my work up in Southeast Alaska as a videographer and then photo instructor and naturalist on board National Geographic Lindblad expeditions, cruise ships. I started working in environmental education when I was a teenager with Portland Parks Recreation, environmental education, nature day camp. I was an outdoor guide in college, and then have a background in documentary filmmaking, wildlife photography, conservation storytelling. And for those last 3 to 4 years, I've worked and had the privilege to be in Southeast Alaska and across the Pacific Northwest in British Columbia and Washington and Oregon on the Columbia River and Snake Rivers, and down in Baja California, Mexico, and the Gulf of California, as well as trips down to Antarctica as a naturalist and photo instructor. And Alex Harper is also the same job as I do, and I've been able to work with him in those places the last few years. And we've collectively been able to really, truly bond over our love of birds, but also see these places changing, especially talking with naturalists that have been in those places for over 30 years and talking with indigenous leaders and tribal elders about the changes they've witnessed throughout their lifetimes and generations is something that I am hoping to bring to the forefront of my science communication and education on these cruise ships. And the majority of the guests we have were on 60-person to 100-person passenger expedition vessels. So we are doing week-long voyages where we're taking guests through glaciers and iceberg fields to islands and whale watching and bear viewing and bird watching, and giving lectures and presentations every day throughout the voyage on all sorts of natural history and the life history of the wildlife and the geology that we're seeing. And I have kind of come to the point where I think it is a responsibility of science communicators to prioritize climate communication in their environmental education. I do really quickly want to give a shout out to my friend Alex Harper at the Red Rock Audubon Society, who did not expect that I would get, he didn't know I had these photos. Just want to quickly thank you for your love of birds has inspired me and was one of the catalysts on my journey here. So that was a big part of that. So I wanted to embarrass you very quickly. But a lot of my work that I travel on is part of the Pacific Flyway. Nevada is also part of that flyway of over 1 billion migratory birds traveling up all the way, in many cases, to the Arctic, to Alaska, and the northern parts of Canada, all the way down through Central and South America, down to the southern tips of South America. And this is a crucial pathway for birds that are using these areas that are relying on wetland habitats, coastal habitats, and all sorts of marine, pelagic, and forest ecosystems to thrive and to survive very quickly. I'm just going to change a setting real quick. Pardon me 1 second. And where we go is part of the Pacific Flyway in Southeast Alaska. And Southeast Alaska in particular is so unique because it is on the ocean in the North Pacific, which is a heavily sensitive area. It is also part of the temperate rainforests and the coastal temperate rainforests. And it also has these glacial subalpine environments. And because of that, it is uniquely sensitive to all sorts of different changes. When I give these talks, the kind of context that I like to set up is sometimes people don't know anything about birds, very bird curious. And so the initial part of this presentation that I emphasize is just getting them familiar with what are the birds around here? How do I identify them? What do they pay attention to? And what parts of ecosystems can they see those birds? We start out seeing a lot of pelagic birds, seabirds out in the marine environment, including loons. I find it really helpful to help guests be able to identify all sorts of specific identifying markers and the shapes of the birds, their flight patterns, their habitats, and really reminding folks that it is a big kind of process of elimination in a lot of ways to understand what the birds we're looking at are, but also thinking deeper about what are their ecosystem functions. One of our favorite birds up in Southeast Alaska and across the Pacific Northwest that is heavily declined and is critically endangered off the Oregon and California and Washington coasts is the marbled murrelet. That was the bird on the front cover of this presentation. They have a really cool evolutionary adaptation where somehow they managed to dive underneath the water the moment your camera gets in focus. Although one of my favorite birds up in that region is the ancient murrelet that I've only been able to see a handful of times. Pigeon guillemot. I'm just going to run through some of these as part of this presentation. Arctic terns, and then we have a whole plethora of shorebirds that are migrating all across the California and Nevada, inland to all these wetlands and lake systems, and also coastal birds, birds that are on the coastline, on the tree line, looking for fish, looking for prey, perched up. And we see lots of bald eagles, thousands of bald eagles, hundreds of belted kingfishers in that area, which is one of our favorite birds up there. And just kind of helping guests identify those birds, great blue herons, and all sorts of songbirds as we go into the forest and all sorts of arid grassland environments. There's all sorts of incredible songbirds. And many of these birds, if you are a birder and you've been birding for a long time, you often just hear, and you are luckily able to get a chance to see them. One of the favorite birds in Southeast Alaska is the Pacific wren. And this has over 100 unique individual notes, and it's called one of my favorite bird songs in the animal kingdom. And I think Alex can agree that it's one of our bird favorites. I share guests the importance of Merlin Bird ID and eBird as really helpful tools. Many of you are very likely familiar with it as a bird identification app from the Cornell Lab of Ornithology that can help you identify the birds you're seeing. And again, as that process of elimination to look up a bird, see its migration pathway or where it will be that time of year, and then helping narrow down if you can expect to see that bird that time. You can use your microphone to listen to the birds. It'll identify the bird for you. It's a truly fascinating app, and it ties in with a really incredible citizen science app called eBird. And eBird is one of the tools that is truly informing bird population decline. Because as a citizen science app, folks from around the world are able to submit checklists of the birds they're seeing and where they're seeing them and when they're seeing them. And it's a year after year after year tool to understand where are birds no longer appearing to, where they may be reappearing to in larger or smaller numbers, and how are they trying to adapt to their changing environments as seasons change and weather changes. A third really cool resource for people interested in birding and following bird migration is a website called Birdcast. And Birdcast uses Doppler radar to track bird migration throughout the sky. And it can tell you throughout the fall migration or the spring migration what sorts of birds you might see in your area, particularly what nocturnal migrants. Many birds, shorebirds and songbirds, migrate during the night. It's colder and cooler, so it's less energy expenditure on their bodies. It's also safer from predators. There's less raptors and aerial threats for them in the night sky as they're migrating. And though many of them will spend the day foraging and eating and getting some shade and protecting. But many birds do still migrate during the day as well. This is a map that Birdcast generates, and you can see it from every single day. This is a screen video from a night in last September on the fall migration south that tracks the bird migration. The brighter color is the higher amount in the 50th thousands. At this time, there's 400 to 500 plus million birds in flight. I'm going to play this video for you right now. And notice that red line going across, that's the sun setting. As the sun sets, all these birds are migrating south, all across the US, all across Nevada, Pacific Northwest, and especially in the Midwest, from Michigan and in Illinois. And then that yellow line is the sun rising, and the bird migration slightly ceases quite a bit. That went all the way up to 500 million birds, and that's just one night. There are estimated several hundred billion birds throughout the year, and over about 11,000 or so, 9 to 11,000 species of individual birds. When I'm out birding with folks and getting them interested in birding, I try to break it down to different ways to understand. And these are some tools I actually learned from Alex Harper, and kind of different modalities and elements of breaking down bird identification. First is the context. Where are you? What time of year are you? What kind of environment are you in? And what migration season might you be in, to narrow down what kind of bird you're seeing. And then what is the size? How big is it? How rotund? How is the angle of the feathers? Does it have a raggedy crest like this belted kingfisher, or a very stout or curved bill, thin or narrow? How do the tail feathers look? And then its behavior. How is it moving around its environment? And what is this environment? If you're in the forest, is it bopping from tree to tree or from limb to limb really fast? Is it on the forest floor in a grassy or shrouded or covered environment? Or is it just soaring or perched on top of a pole? And all of these are different behaviors that different birds will or will not do. Plumage can often be misleading. The color of a bird can often be dependent on the time of year and the specific morph of that bird. Many red-tailed hawks don't have a red tail. You have to go by other indicators to identify that bird. And if it's in its breeding plumage, its alternate plumage, or its winter or basic non-breeding plumage, that's going to be a different color. And then its sound. What kind of calls and songs are it making? What time of year might they be making those mating calls, or those calls from a chick to a parent? And all this to kind of have a deeper appreciation for birds, to really understand what are the true ecosystem functions of birds and why are they important in environments across the world. Because birds truly are sentinels of environmental change. They're indicator species for all sorts of environmental impacts that are affecting human health, human economies, human infrastructure, and are a reflection of the ways that humans and other changes are impacting our world. One of the biggest ecosystem functions of the 4 different functions that birds play is as seed dispersers. And they are crucial plant spreaders, and they're recycling carbon and nutrition in the forest. And they are helping to disperse them, whether by dropping them as they fly or defecating and releasing seeds throughout the forest. And this is helping to create more trees and more plants that will feed more animals, feed more humans, and also in terms of spreading that nutrition. And the human labor costs of replacing those birds and their impact is truly immeasurable. I'm going to try my best in this talk to put some sort of relative numerical or financial number to it. Often I think when we talk about climate change, it's these future projections of cost, right? People don't care as much unless there's an impact to them or to their economies. And so I think it's important when we talk about climate change and we talk about animals and wildlife, there is that interconnectedness because we do rely so much in ways many people don't realize on animals and on birds to impact humans as well in our lives. Second function is as pollinators and birds that are pollinating plants, hummingbirds in particular, other birds as well, all across the world. There are some plants that are heavily distributed by birds as the main source of pollinators, along with other insect pollinators as well. These are plants here on the screen are fireweed and lupin. These are really important keystone species in Southeast Alaska and across the Pacific Northwest. These are plants that are stabilizing forest zones, riparian zones that are coming in after disturbance. Plants that come in after fires need to stabilize the soil, start a process of bringing nutrition and nutrients back to their environments. A third role is as insect and pest control. So birds are protecting crops, they're preventing insect booms and plant die-offs. There in 50s or so, in the 1950s, there was a massive famine. The Great Famine in China was about 15 to 55 million deaths of humans that was a result of the eradication, the partial result, the eradication of sparrows that then led to an increase in insects that killed crops, that then led to human deaths. So all these chain reactions that are often overlooked or unpredicted in the times beforehand. A fourth and final role is as our nature's cleanup crew. In its lifetime, a single vulture provides waste disposal services worth over over $11,000 in its lifetime. There was an incident several decades ago in Southeast Asia where there was massive die-off of vultures. That massive die-off of vultures led to an increase of feral rabid dogs, which led to over 30,000 human deaths from rabies. So all these, again, these chain reactions that can often be unpredictable. They kind of seem gross, right? They kind of seem like scavengers, and they are, but they're really important, and they have really crucial ecosystem roles that they play. So when I'm giving this talk, this presentation I'm doing now to you, I'm kind of doing from a little bit of a meta perspective and hoping that people here with us right now might be in places where you are trying to figure out how to communicate differently or more thoughtfully about global change, especially in the context of birds. And that's a really hard thing to do. And it's really hard to do on the ships because often I'm giving this talk at 9 p.m. to a handful of 40 or 50 slightly inebriated people. And they're there on a Nat Geo trip because they care about the natural world, they care about the environment, and they want these tools, but they're also on vacation. So I appreciate people being here, intentionally choosing to be here, because it's a really hard thing to talk about. And it's heavily stigmatized. And we've been fighting all sorts of misinformation and propaganda for decades and decades. And it's a vulnerable thing to talk about. And I get nervous and anxious talking about it. I think everyone might experience that depending on who you're talking to and what kinds of things you're trying to say. So I just want to give that a little bit of a preface because it's a hard thing to do and I appreciate everyone being here. In order to have a little brief history of some climate science, and again, many of you might be familiar with some of this, I want to go back a couple of decades to the world's most famous ice core. This is an ice core sample taken from, you might know, from the Vostok station, the Russian research station in the 1990s. That was over 3,600 meters deep. This, at the time, was some of the thickest and therefore the oldest ice found anywhere in the world. And it was one of the things that gave us a true initial glimpse into our past Earth climate. Scientists able to take these ice cores, drill deep down, and take those cross sections to get the oxygen isotopes and understand the climate at the time, dating back at this time over 420,000 years ago, which has been corroborated now close to 800 plus thousand years ago through continued research in ice core drilling. And it is an incredible modeling of the past climate. And it showed these massive long-term trends that scientists were able to start to piece together, along with other research, that the Earth's climate has varied cyclically and predictably in recent geologic time. These are glacial and interglacial periods. As the temperature goes down, the Earth gets cooler, and the ice ages spread. That's a glacial period. As it warms up, it's interglacial as the glaciers and the ice sheets retreat and melt, and the sea level rises throughout the world. And that is a process that is repeated time and time again. And these processes happen on 40,000 to 100,000 or so long periods of time. This graph you might have seen before is compared with CO2 in the atmosphere, carbon dioxide parts per million in the atmosphere, as we have these glacial and interglacial periods going back and forth for close to 1 million years. As we reach this modern time, that right side of the map towards the zero, that's towards present day. Throughout these periods of time, the peak CO2 parts per million was always about 280 to 300 parts per million, and lowered down at its bottom about 180 parts per million, very predictably and very cyclically. As you would expect, you might expect we would plateau off in that area. What do we just start doing? Towards the end of the 1800s, humans started burning fossil fuels, and that number has continued to rise and rise. Towards the early 1900s and the start of the oil and gas industry, I have to add some fun transitions because, again, sometimes I'm giving this at 9:30 p.m. at night on a ship, and many people would rather be looking for whales on the bow, and I certainly don't blame them. So thank you for putting up with some fun little transitions. One of the things that this ice core really reaffirmed was a research done by this scientist, Milutin Milankovitch, who in the 1920s developed the research known as the Milankovitch cycles. And these are these long-term explanations for these trends that the Earth goes through with its warming and its cooling, depending on the angle and the tilts and the eccentricity of the Earth. As the poles in different parts of the Earth are further and closer away to the sun, they'll experience cooler and warmer periods of time, again, over these tens and hundreds of thousands of years period. Think of it kind of like when you're standing at a fire. Your face is facing the fire and it's getting all that heat, but the top and the back of your head are much cooler and not getting that cool. As you rotate around, that heat exchange will change. And that was a reminder again of what can explain these massive long-term trends. And I think it's important to note that this science and these researchers that understood and developed the idea of the greenhouse gas, these are from the 1800s and the early 1900s. These notions, this science was developed across borders and well before any of our modern political systems and parties existed in the form that they do today. One of the key founders is this woman, Eunice Foote. Eunice Foote was the first scientist to truly do the experiments that understood and developed the idea of a greenhouse gas. She did the experiments that developed the notion that CO2 traps in heat in the atmosphere. And she is quoted as saying that an atmosphere of that gas, of carbon dioxide, would give to our Earth a high temperature. This is from about the 1850s or 60s. A couple of years later, after she did her research, a scientist named John Tyndall would do a more in-depth research of the same concept and would get the credit for this and become considered one of the fathers of climate science. I think it's important that mention Eunice Foote did this as well, and she was awesome. So what does this tell us? This tells us essentially that the CO2 is a thermostat of the Earth, and CO2 parts per million in the atmosphere correspond directly with global temperatures. Since the beginning of that new age, essentially the anthropogenic age of human impact on the Earth, humans have burned over 1.5 trillion tons of CO2 that has been emitted into our world, into our air, onto the land, and absorbed into the oceans. This is a graph that shows the blue line of what global temperatures would be like today without any human influence. As we reached that top peak, it would have plateaued and stabilized. And now we're able to attribute human generated influence. And the red line is what we have today. This is from 2017. It's now reached up to 1.5 degrees Celsius. And that is really interesting part of a newer emerging climate science of attribution science, being able to understand what the natural changes have been, what are the changes now, and measuring that difference to be the human generated impact and input. And we know what happens during those periods of change. We know what happens when massive amounts of CO2 are injected into the atmosphere. So regardless of what people are saying is causing those ejections of CO2, or if it is even something to worry about, which it is, we have references of past events, massive extinction events. This is an example of the Permian Triassic extinction. This was nicknamed the Great Dying, and it wiped up to 95% of marine life and wiped out up to 70% of life on land. This was at a time when massive volcanic activity was injecting a lot of CO2, greenhouse gases into the atmosphere. CO2 parts per million at this time were much, much, much higher than they are today or predicted to be in the near future. And scientists for decades have been aware of this. Presidents since the 60s, since JFK, every single president since JFK has known about this. Their advisors have known about this, conversations from scientists in the government, and every decade onwards has tried to bring this attention to the White House, to our governments, and to the international arena. This is a paper that I want to share from 1979. So some research that shows what the impact of CO2 and the concentration will be in the atmosphere. I'm going to read this really quickly, but I'm going to come back to this because it's very fascinating. CO2 concentration in the atmosphere has increased since the beginning of the world industrialization. It is now 15% greater than it was in 1850, and the rate of CO2 released from anthropogenic sources, human-generated sources, appears to be doubling every 15 years. The most widely held theory is that the increase is due to fossil fuel combustion, that increasing CO2 concentration will cause the warming of the Earth's surface, and that the present trend of fossil fuel consumption will cause dramatic environmental effects before the year 2050, all of which has been confirmed to be true. This is over almost 50 years ago. This is some other excerpts of that piece, of that paper. On the left, that most of the glaciers in the North Cascades and Glacier National Park would be melted, marine life would be markedly changed, and ocean levels would rise 4 feet. This graph on the bottom right turned out to be a fairly accurate prediction of what potential surface change of temperature we might experience today. And I'm going to come back to this in a little bit. For example, we have burned, a couple of years ago, we've now hit the point where we're burning over 35 billion metric tons of CO2 every single year. If anyone recognizes this is El Capitan in Yosemite National Park. It is about 1 kilometer tall and 1 kilometer wide. And if you took the height of El Cap and turned it to make a full 3D cube and filled that with gas, with CO2, that would be 1 billion metric tons. You'd have to take over 35 cubes the size of El Cap to equal the amount of CO2 emitted in 2023. I think we're now over 36, 37 billion metric tons in the last few years, every single year. That is an incredible, astounding number. That is huge. And where are we today? Again, that pre-industrial range was very reliably and over a long term, fluctuating between about 180 to 280 and 300 parts per million in the atmosphere. Today, atmospheric CO2 is about 430 parts per million. In the atmosphere, that's a number we have not seen in human history or in well beyond human history. And it's estimated we could exceed 800 parts per million by the end of the century. Some more fun transitions. And the average global surface temperature since pre-industrial levels is 1.5 degrees Celsius warm. Now, as of last year, 2 degrees Celsius is considered safe warming, quote unquote. Last year was recorded as the warmest year on record. This is a graph of the global average surface temperatures dating back to the late 1800s. And these are temperature anomalies that are only getting increasing. We see a lot of change in Alaska in particular because the polar regions, especially the Arctic and the North, are particularly susceptible to this warming. Alaska has warmed at over twice the rate, and the polar regions are warming, Arctic region is warming around 3 to 4 times the rate than the rest of the US and the rest of the world. And Alaska is projected to continue warming extremely rapidly, especially at high latitudes. In Alaska, there's about 100,000 glaciers. 95% of those glaciers are in active retreat. They're losing more ice on the face than those glaciers are advancing forward as a moving river of ice. Ice is being fed in from the ice sheets that feed in all these different glaciers. As the glaciers are retreating, they're also deflating downwards. So they're going back, they're not as long, they're not as tall and thick either. And when that happens, the ice becomes a lot dirtier, becomes a lot less reflective of that sunlight, and it's absorbing more heat. And that ice albedo effect essentially is a positive feedback loop, that as it gets dirtier and warmer, it continues to melt more and more. And that is changing habitats, it's changing landscapes, it's changing animal habitats and bird nesting habitats all across Alaska, all across the Arctic region. One of the things Alex and Harper and I see a lot are the ways that retreating glaciers will affect harbor seal, haul out, and pupping habitats where they give birth. And a glacier that touches the water, that comes out to the ocean water, calves off ice onto the front and creates floating ice and icebergs and pieces of ice that float on the water. That is called a tidewater glacier, and it's creating all this habitat for all these seals. But when a glacier retreats up onto land, the ice is no longer falling onto the water in front, it's now falling onto the land in front. And now there's no ice floating on the water for the seals to pup. And more glaciers in Alaska, and Southeast Alaska in particular, are becoming valley glaciers, where they're up in the mountains, they're no longer tidewater glaciers down in the ocean. There's also all sorts of effects on the marine environment to that as well. When a glacier retreats up onto land, it's not ejecting as many minerals and nutrients into the ocean. Those minerals and nutrients that are feeding out in the ocean are feeding the marine food web. They're feeding the plankton that feed the fish and the krill that feed the birds and feed the fish that feed the bears and all sorts of interconnected webs. And so all these interconnected things. But Alex, you might be wondering, don't forget about the birds. Well, let's talk a little bit about how these changes with this warming world are affecting bird habitat and destruction and bird and habitat fragmentation, nesting site loss, food availability, migration patterns, all kind of within the context of reproductive success and survival, right? That's really the point of all these impacts. And there are other things I'm going to talk about. I want to start with heat waves, because that's the things that I think we're seeing a lot of across the US, in the North Pacific in particular, is experiencing more frequent and severe heat waves. And as these weather systems, as storms and heat waves and droughts are occurring, they're continuing, as we've all seen, to get more frequent and more severe and last for longer. So their intensity, their frequency, and their duration is increasing. These are some photos of some mers and puffins from an event from 2014 to 2016 called the Blob. The Blob was a Pacific marine heat wave that started in late 2013 and early 2014 as a massive blob of warm water that started appearing off the coast of the Pacific Northwest. It spread outwards towards Alaska in 2015. By 2016, that heat had spread all the way up through the Aleutians up into the Bering Sea. And as that blob expanded, it massively disrupted all sorts of marine food web ecosystems across the land that then affected terrestrial animals as well. It completely jostled the marine food chain, and it led to heavy mortality events among humpback whales. It killed over 1 million seabirds. It had all sorts of trickle effects on wildlife ecosystems. One of the things that a really warm blob of water does is it doesn't just spread out, it spreads down. And the thicker the warmer water, the cooler water below is able to upwell and cool and cycle that surface water. So the surface temperature continues to get warmer, continues to get deeper, but all the nutrients are below in that cold, nutrient-rich water, and they can't come up to cool the surface. So the surface is staying warmer and getting warmer at that time, and it's also eliminating the ability for food to grow, for the plankton to grow, to feed up the food web. And that killed over 1 million seabirds across that area. I am from Portland, and this is something my parents experienced, and this trickled all the way down to California and Nevada. This is a map of the 2021 Pacific Northwest summer heat wave. This was a period where there was, I believe, over 4 to 4.5 degrees of warming, more than normal. That red line in the graph on the chart on the bottom left was how out of normal range that the summer heat wave was. My parents were living in Portland. I did a road trip down through Oregon into California at that time. Temperatures were over 100 degrees, and it was just another reminder of these continuing heat waves that are getting longer and more severe and happening more often. This is another graph. This is the projecting some future trends of summer temperatures across the Pacific Northwest. And that is a red text 2021. That is the heat wave from that summer, from a few years ago, eking out to the top anomaly up in that trend. And yes, there are some fluctuations. And I think this is a really important note when I'm communicating about climate, is noting that variation, these highs and these lows, there are going to be really cold moments, and there are going to be extra heavy rainfall and snowfall. It's important to note that variability is inherent in the climate cycle and in the climate process. And that is one of the interesting kind of gotchas that a lot of climate deniers try to impose, is that finding these examples of extreme cold and extreme heat to deny the effects of extreme cold and extreme rain, to kind of debunk these warming trends. But it's kind of like holding a sandwich and saying that people aren't starving somewhere else. One of the things when climate change got really brought to the forefront in the late 1980s, when scientist James Hansen testified in Congress, was truly saying out loud for the world to hear that the warning signs are happening now. This was in 1988. One of the things he wished he had a better opportunity to also emphasize was that not only are things going to get warmer, but there are going to be more frequent and severe storms and cold and wet events. Because as the temperature warms, the atmosphere, a warmer atmosphere, is capable of actually holding in more moisture. And with that more moisture, there will be higher offloads of storms and floods. These storms and floods are getting, again, longer and more frequent. One of the things that we might hear more about, we're continuing to hear, are these 100-year floods that are now becoming 50-year floods. That doesn't mean that that flood happens every 100 years. It means that every year there's a 1 in 100 chance of that flood happening. That's a 1% chance. For a flood to become a 50-year flood, that means there's a 1 in 50 chance, or a 2 in 100 chance. That is doubling, essentially, right? The probability that that flood will happen. What floods and storms will do is it massively destroys bird habitats. It's disrupting breeding timing and migration timing. And one of the things it really impacts is it makes birds miss out on the peak abundance of food. When birds are migrating to an area, they're used to migrating at a specific time of year and expecting the peak abundance of insect blooms or of fish or of what you name it, of berries and all sorts of prey items. And when that happens, when seasons are changing, when seasons are early and seasons are late, it completely throws them off schedule. They've traveled hundreds, if not thousands, of miles to get to where they need to go to rest over and stop and feed on those ways. And apart from that, it's destroying human economies and infrastructure, and as we've seen lately, quite devastatingly, killing dozens and dozens of people from very predictable events and preventable events. The last of these big changes is continuation of drought. This is a map of the Salt Lake City, Great Salt Lake from 1985 to 2022, where it's lost about 73% of its water. This is a habitat where over 10 million birds rely on every year as they're migrating for reliable and consistent food sources and resting habitat and breeding habitat. I wanted to throw in a couple of things as well about Nevada. This is from drought.gov, which is a program run by NOAA and the National Integrated Drought Information System. These are integrative maps, interactive maps that you can go across your state, wherever you're from, and kind of map out what parts of your state, what parts of the country are under more abnormal or extreme or exceptional amounts of drought. And this is the US Drought Monitor from Nevada, showing about 40% is abnormally dry, about a fifth is moderate drought, and then about a quarter of Nevada right now, especially in the south and including Las Vegas, is considered in a severe or extreme drought right now. And there's about 2.1 million residents that are under threat from drought in Nevada right now. And June last month was measured as the 16th driest month in Nevada in the last 130 years on record. I think that's the last of the fire transition. Lastly, wildfires are not only getting more frequent and severe, they are destroying migration routes. That means that birds that are flying north or flying south have to completely change their pathway to avoid smoke inhalation and to simply avoid dying. That means they either have to go hundreds, if not thousands of miles out of their way around it, or they have to go often 4 times higher in altitude to avoid that fire above it. And that takes a lot of energy. That is taking a lot of energy from these birds that need to get to their next destination to rest and to feed and to continue to raise their young. These, on a human level, wildfires, of course, are destroying human infrastructure. They're taking lives. They're destroying habitat. There's obviously immeasurable billions and trillions of dollars of property damage and loss as well. And then from a continued climate change perspective, this feedback loop of continuing to release more carbon into the atmosphere. A couple of the birds in Southeast Alaska that I'm particularly fond of that are under threat from various sorts of global change or have recovered are bald eagles, marble murrelets, Kitlitz's murrelets, and Arctic terns. Deforestation is one of the biggest impacts on marble murrelets. Marble murrelets are a really fascinating bird. They are a pelagic seabird that spend their days out on the ocean, feeding and fishing, and they are in the alcid family. They're related to puffins and murres and guillemots, and they are a diving bird. They can dive over 150 feet deep to look for fish and to feed. They used to be quite abundant all across the Pacific coast of California, Oregon, and Washington. And they're still around in British Columbia, and they're pretty well up in Alaska, but still quite threatened. What's really fascinating about marble murrelets is they nest inland. They nest in conifer trees high up, 40 feet plus up in coniferous mosses, and they have to go back and forth every single day out past the coast to the ocean and then back to their nests. which means they're really sensitive to coastal development and logging. And their populations now are incredibly critically endangered across the lower 48 coast, those Washington, Oregon, and California, from coastal development. One of their biggest animal predators are corvids, crows, and ravens. One of the things we can do to prevent the threat of corvids is crows and ravens tend to follow humans. We leave a lot of trash, we leave a lot of scraps and debris that will then invite other smart birds like corvids to prey on those items or to steal from humans. And as they go to those areas where humans are disturbing forests, then those corvids will start to be introduced to more marble murrelet habitats. And that has happened in quite many places across the coastal areas. Coastal development and highways and human infrastructure has also really impacted that. Bald eagles are one of an interesting story of conservation success. The effects of DDT from the 40s through the 60s resulted in all sorts of birds that rely on a marine habitat, an aquatic diet, to lay those really thinly shelled eggs. So as it made its way into the food system, DDT and many other chemicals and pesticides are continuing to do this through bioaccumulation and biomagnification. Osprey and brown pelican and peregrine falcons and bald eagles were incredibly threatened. And when Rachel Carson's book, The Silent Spring, came out, it was this big wake-up call. By the end of the 60s, bald eagle populations in the lower 48 had gotten close to only 500 breeding pairs. Peregrine falcons were around 50 breeding pairs in the lower 48, and that was kind of on the verge of local extinction, of extirpation. And osprey populations in places like Boston and New York dropped 90%. This was a really cool example where when we banned DDT in the early 1970s and saw the problem and had the political will to work together to implement enough conservation measures and the bald eagle and golden eagle protections, we've seen the recovery of bald eagles in the lower 48. They were removed from the endangered species list in 2000, and in 2019 they were listed as least concern. So, how do we all talk about these changes? I think maybe we all might have some people in our lives that can be difficult to talk with when we're trying to just share the things we care about. Where we are today is that our planet in the last 50 or so years has lost 70% of all of its biodiversity. That includes about 3 billion birds in the last 50 years in decline. That is a massive amount of decline. Throughout those 50 years, the discussion around climate change has gotten quite political, quite stigmatized, and quite toxic. And I think it's hopefully important to kind of confront some of those misinformations and to understand where some of those perspectives and arguments are coming from. Does anyone remember this that I shared earlier? This is an internal memo of some scientific research from 1979. This was from a paper or from a memo that was not made public until 2015. Because this, what I shared earlier, what scientists realized from the late 1970s was an internal memo from Exxon, now ExxonMobil, one of the largest oil and gas industry companies at the time. And this, in the 80s, and particularly starting in the 90s, started the efforts to really influence public perception of climate change. One of those things is instilling an incredible amount of doubt. And when people were so focused on the uncertainty and the range of potential outcomes, it's easy to let them be distracted and on actually doing something impactful, whether that's international agreements and accords or national or statewide or local conservation policies. that started a whole slew of very fascinating and evolving different propaganda messaging. So, if the Earth is getting warmer, why is Kentucky getting colder? What the most serious problem with catastrophic warming is, it may not be true. A quote from an internal Exxon document said that victory will be achieved when average citizens understand uncertainties in climate science and recognition of uncertainties become part of the conventional wisdom. So, quite brilliantly and quite insidiously, starting to sow these notions of doubt in the public mind. And it's changed over time, right? The messaging has changed. It really truly started with these just flat out denial and doubt. It evolved to be a little bit more, it is happening, but it's normal, or it's not as serious as we make it out to be. Or one of the most impactful things and the most effective forms of propaganda was individualizing ourselves. Who remembers this? The Crying Indian, Get Involved Now, from the Keep America Beautiful. This was from several decades ago. This was a commercial of a Native American man rowing through a river filled with plastic bottles. And it was a campaign to get people to clean up after themselves. The interesting thing about this was funded by Keep America Beautiful. Keep America Beautiful was a organization founded and funded by the plastic industry, by Pepsi Cola and other glass companies in the American can company. And it kind of started this effort to distract people with their own impact. Then one of the biggest things after that is the concept of the carbon footprint. Carbon footprint was a concept created by BP Oil, by British Petroleum Oil, to once again deflect attention onto ourselves, to make us too focused on our own individual footprint and our pollution and our consumption. And I don't want to diminish the effect of that. I don't want to diminish that we do have our own footprints. We do consume and we do emit a lot of fossil fuels, but it is a very effective campaign. And I think it's important to really be aware of where that came from. And it came from the oil and gas industry to distract away from them being those main sources of emissions and greenhouse gas emissions into our world. One of the effects of that, which was quite effective, was it lets people think that they can recycle and compost and that their work is done. By all means, recycling and composting and consuming less and driving an electric vehicle and avoiding fast fashion and all sorts of things can be very impactful and added up together, but it's not the whole picture, and they're not effective if that's the only thing that's being done. As people became a little bit more aware and as those propaganda machines started to evolve with public perception, organizations started different forms of greenwashing, different forms of giving an outside perspective, this illusion of sustainability, that they are pledging for different climate pledges and trying to do green energy and all these sorts of things that they all eventually backed off from because it wasn't making them money. British Petroleum dialed back their climate pledge. And this is a parody article, but BP changes name to Barely Progressing, announces new beyond net neutral zero carbon offset, hopefully maybe by 2100 goal. I think that's pretty funny. So I think it's important to note that this happened because there is so much money to be made drilling fossil fuels. And this is money that oil and gas industries consider real money, even if it hasn't yet been extracted from the ground. And they treat it as actual value. The remaining oil and gas still in the ground that has yet to be drilled is worth about $20 trillion. So why would they stop? Why would they have any incentive to do anything otherwise beyond public perception? Right now, fortunately, we are experiencing a clean energy revolution. This is the decrease in price of solar photovoltaic module price, so dollar per watt of energy. It's one of the fastest decreasing prices of any technology in history. As of a month ago, or about 3 weeks ago, this was a relevant slide that is no longer relevant as much. Many of these tax incentives and clean energy subsidies have been cut with the latest bill, but this was at the time, the Inflation Reduction Act was at the time the largest climate bill of all time. And it did a lot of great things, could have done a lot more things. We can always do more. I always think there's more to be done. It's not a negation on the efforts that have been made, but it's just kind of optimistic, hopeful perspective. Of that growth we're experiencing right now, solar is winning the energy race, and we need everything we can get. We need every form of technology and sustainable green energy that we can get. I think it's important to note that it's always about comparing technology to past existing technologies, right? Because none of these green energies are truly green. They all rely on extraction. They all have a footprint. They're all ripping things out of the ground, whether it's lithium and different minerals and metals and fiberglass to make different wind turbines and batteries and solar panels and whatnot. But it is the trend, and it's happening whether certain governments like it or not. One of the biggest differences in solar installation is the cost. Not the cost of the technology itself, but the administrative costs. Installation costs in the US are about 3 times more than in Australia, even though it's the same technology, because the administrative costs are a lot more expensive. So bridging the gap on administrative installation costs would make a huge difference in solar implementation. This is another graph that shows the increase of solar installation and solar capacity from 2017 and projected trends towards the next 6 years. And it has surpassed almost every form of other energy so far, right? In 2017, it passed nuclear, then it passed wind, then it passed hydro, then it passed gas. Well, didn't, you know what I mean. And then this year it passed coal, and then it's projected in 2031 to surpass everything else combined. That is incredible. And not every region, not every state, not every country is going to rely as equally on different forms of these technologies as their geographies and their climates are different. And that's why embracing all of them is really important. One of the things now that we're seeing is trying to sow doubt in these technologies when it comes to misinformation propaganda about wind turbines off the Atlantic coast killing whales, which is funded again by the oil and gas industry, or kind of these deflection mechanisms to negate the effect of wind turbines. I think many of us might have heard about the effects of wind turbines and wind turbine strikes killing birds. And again, this is true. There's around 100 to 300,000 birds that are killed every year by the blades on wind turbines. But relative to other pre-existing energy and electrical and oil and gas infrastructures and oil spills, it is a tiny, tiny fraction of the millions and billions of birds that are killed by building strikes and electrocution and pesticides and all sorts of toxicants and oil spills in the environment. So it's all kind of relative, and I think it's also remembering when we're seeing these headlines and we're seeing or we're hearing these talking points from people that we trust or people that we know and love, it is where is that information coming from and who is benefiting from sowing doubt in these technologies. And what's really cool is there's ways to improve these technologies that are already being done. There was a 9-year study out of Norway that showed that if you paint black one of the blades on a wind turbine, it decreases bird strikes by about 70%, which is really, really cool. So there's these ways to improve them, right? This is a graph of some of the top killers for birds. You might know what the top one is, and we'll get there together. The bottom one is wind turbines. Then we have electrocutions, 5.6 million. Electrical line collisions, 25 million. Poisons and other pollutants and toxicants, 72 million. 214 million from collisions with vehicles, about 600 million from building glass collisions, which is why lights out movements across cities and reflective decals on windows can be quite effective. And then, of course, over 2 billion birds from cats every year. I'm not calling anyone out, but that is the leading statistic right now. I didn't make this. There's also a lot of other big wins happening on local and state levels that aren't getting talked about. I think part of this despair that a lot of people are feeling is these wins aren't being publicized as much as they can be. There's a lot of powerful movements happening, people that are bringing the fights against big oil companies, different landmark case. Many of these are being led by tribal groups or being led by young activists, and we're simply not hearing about them. So looking for them because they're out there. One of a really powerful movement right now that's continuing to gain traction and that has true financial pressure is the divestment movement. So working and protesting to get all sorts of organizations to divest from fossil fuels. There are trillions of dollars from different banks and organizations that are either in loaning or insurance companies that are insuring drilling projects that are facing increasing pressure to stop insuring or to stop funding or subsidizing or loaning out to different fossil fuel industries. And this can be banking with faith-based organizations, with governments, with universities, that is in the tens of trillions of dollars of pressure. And again, this is one of the biggest movements because, as we know, this whole problem is being fueled by money and power. And again, that $20 trillion of remaining oil and gas that's still in the ground that has yet to be drilled and extracted is at stake for a lot of these companies. Another really cool technology I wanted to point out is another thing that some companies are playing around with is different decals and different stripes on wind turbines to reduce bird strikes. That picture on the left is supposed to emulate predatory eyes of a predator to dissuade birds from getting close. And then the stripes on the right, again, break that illusion that's hard for birds to see. Many of the birds that get killed by wind turbines are raptors that are either perching or looking for other prey and birds to prey on. And I don't know, I'd be pretty scared to go close to a wind turbine with those two eyes staring me down. But this year has been one of the biggest years in raising the alarm for bird decline. Organizations across the world and the recent Cornell Lab of Ornithology is posting with their new report, well, this article about the new State of the Birds report. And these are calling for massive conservation actions now that are trying to combat the threat of all sorts of bird decline. One of the things that just recently happened is a weakening of the most important bird act at the national level was the executive order a few months ago that weakens the Migratory Bird Treaty Act. What this order did was strip the ability for the Migratory Bird Act to hold accountable the incidental harm and killing of birds. Right now, the Migratory Bird Act since 1918 allows the government to hold accountable intentional or incidental take of birds. So that's the harm or the killing and so forth of animals, even though it hasn't fully been defined in the act. It was the act that was allowed to be used as part of the lawsuit against the Exxon Valdez oil spill, against the BP oil spill in the Gulf, that resulted in those companies paying millions, if not billions, of dollars. $100 million for the BP oil spill in the Gulf of Mexico. What this means is an unintentional or incidental killing of birds will no longer be able to be something that an organization or an oil spill can be sued for. This was first tried in 2017 and then was overruled by that next administration, I believe, or through a lawsuit. And then it was appealed, and then that appeal was overturned in the next administration. And this latest administration, once again, is trying to do this. And the reaction to this from April was the month after, in May, a bipartisan bill was introduced into the House of Representatives to the Natural Resources Committee of the Migratory Bird Protection Act of 2025 to reinstall and kind of undo the weakening of the Migratory Bird Act. I'm truly not sure on the status of this. This is introduced, I believe, last 2 months ago. And that's one thing that I think, if you're interested in reaching out to any representatives, this was a bipartisan bill from a California representative. This is an act that would hopefully have a chance to reinstall some of the strong powers of the Migratory Bird Protection Treaty. The State of the Birds report that just came out this past year showed a massive decline across almost all birds in population change. Some birds are doing okay than others, water birds and other certain kinds of ducks, but the western forest birds, eastern forest birds, shore birds, and then in Nevada, as an arid grassland area, almost 40 to 50% decline in arid land birds and grassland birds. One of the things that the State of the Birds talks about is the financial input or output generated by birding. Birding is a $279 billion industry. The amount of money that's spent on travel, on equipment, on the taxes paid from birding activity is $279 billion. And I think this is a really strong number because, again, it's putting into human economic terms the effects of these changes and how important birds are to people across the world, across this country. And hopefully it's something that will continue to be taken seriously. In Nevada, the Audubon Society has released their Survival by Degrees, 389 species on the brink. And in this report on the effects of different climate-related threats to Nevada habitats for birds, they've noted that the distribution of vegetation biomes critical for plants and animals are also projected to change under climate change scenarios. By the end of the century, under a 3 degrees global warming scenario, approximately 44% of the state of Nevada will transition to a different biome. Essentially, almost half of the entire state will change ecosystems. The largest biome is a desert scrub. By the end of the century, the desert scrub will expand to cover about 85% of the state. And that will destroy habitats for humans and for birds. Species that are most threatened, that are by additional climate-related threats under that 3 degrees Celsius of warming, include the spotted sandpiper, the yellow warbler, the sage thrasher, the American robin, and the black-billed magpie. The 6 key threats that this report looks at is the effects of urbanization, the effects of cropland expansion, extreme spring heat, fire weather, spring droughts, and false springs. The map on this resource shows the effects of different climate-related threats in Nevada under the current scenario on the left of 1.5 degrees Celsius, and then the projected 3 degrees Celsius of warming. Every single one of those squares represents either 0 threats or 1 or 2 or 3 of those 6 different climate-related threats. So under just a 3 degrees warming, about half of the state of Nevada would be experiencing about 3, at least 3, of those 6 different climate-related threats, whether they're different expansions or false springs or droughts or urbanizations and so forth. One of the things that a climate mentor of mine told me a couple years ago is that he believes that whatever the current warming is, which is 1.5, that everything is already in motion. Even if we stop burning fossil fuels now, everything is already in motion to reach double that, no matter what. That is not necessarily a pessimistic, perhaps just a pragmatic, but very upsetting view, but very, I think, sombering thing to think about. That it's very, very likely that we will hit this scenario. A couple resources I think are worth checking out are from the Yale and George Mason Center for Climate Change Communication. They do some really fascinating public surveys and studies to understand how human perception, how public perception in the US and around the world has evolved and changed, and what are the things people truly care most about, and breaking up these different parts of the American mind. And one of the things they're finding is that the things people care most about are creating a better world for their children and grandchildren, and protecting biodiversity of life, of human and animal life, and plant life. And I would highly suggest checking out these resources from their websites, the George Mason and Yale Climate Change Communication. They co-publish and do their research together. And it's a really helpful tool to understand how people are changing over time. One of the things they also do is they recognize the importance of credible sources of information. And they have a program where they are providing resources and information to locally trusted people. Who are some of those locally trusted people in an area is weather reporters and meteorologists on local news channels that they are working with to try to increase local climate communication, as well as even like a pediatrician to talk about the respiratory effects of a warmer planet. Another incredible resource are the climate assessments. This is the 5th National Climate Assessment from about a year or two ago. These are really extensive and exhaustive resources that break down the way climate is affecting every region around the world, around the country. It is from the US Global Change Research Program, but it is funded through the government. And you might have heard that the funding for this next climate assessment that was already been underway, the 6th National Climate Assessment, was cut this year. And I'm not sure on the status of that right now. One of the really tough parts about that being cut is that many cities, many small towns that don't have the resources to do their own studies and assessments rely on assessments like this to make their decisions and their policy changes, so that they know how to adapt and evolve to either adapt or to mitigate from extreme droughts or incoming floods and wildfires. And so that is a really important tool for a lot of these poorer states and poorer cities, and just anyone anywhere who wants to have a deeper understanding of their own region. I really wanted to quickly share as well the Sierra Valley Nature Center. I'm going to wrap up soon. I know we're pushing time. Appreciate that. The Sierra Valley Nature Center is just about 45 minutes outside of Reno and across the border in California. That is one of the most crucial migratory and breeding areas that I've ever been to. And I got to work with the creation of the center to do a film installation in the entryway. And if you're looking for some incredible birding a couple hours away, I would highly suggest checking out the Sierra Valley up in north of Truckee. A couple of resources you're welcome to screenshot. These are some books I've either read or right here on my pile to read that are really helpful understandings of the history of climate and its change in our world, or some upcoming energy programs and the influx of solar energy, and a couple cool bird books you might have heard about. On the top left is just a 45-page book from Nathaniel Rich called A Recent History, about the closest we ever got to making actual policy changes. And that is, I just finished that this week, and I would highly recommend starting that. I think you can probably find it online as well. So as I wrap up, I appreciate all of your time. I think you're all here because you care about birds and you care about our world and our environments. and hopefully just a reminder on how incredible and adaptable birds truly are. How these dinosaurs have evolved to every different habitat, how incredible they are at flight across the world, across the oceans, but they're also weird and stupid and silly and quite entertaining and just bring a lot of people a lot of joy. And they also love and they're affectionate and they're thoughtful and they communicate and they're capable of so much more thought and emotion and memory and communication and planning than we ever thought. And we're only just starting to learn more and more about them in the last few decades. So, beyond the small personal things, whether that's outdoor cats and native plants and pollinators or decal stickers on windows, I think it's important to embrace the notion of being an imperfect environmentalist and not being upset that you can't do everything. I can't do everything right, and that there are all these things we can do, whether that's an electric vehicle or challenging fast fashion or lowering our consumption. But none of it truly matters if we don't decarbonize our energy systems and electrify our energy systems. And also just simply reduce our consumption patterns. It doesn't make a difference as much if we're still doing the same things. I think part of that is people are afraid to let go of their luxuries. And I get that. And it's really hard. It's really easy to give things to people, to give luxuries to people. And it's really hard to take it away. But that's just what they are. They're luxuries. And hopefully, as we embrace the idea of being a perfect environmentalist, part of that for me is being a climate optimist. And climate optimism isn't passive. It isn't hoping that things will get better or the next generation will fix it, because we're all still alive now, but recognizing that every ton of CO2 emissions reduced will make a difference in reducing human and animal suffering. People are going to die, animals are going to continue to die, things will change. But every CO2 emissions, every ton of emissions reduced will make a collective difference in reducing some of that suffering. And part of that collective difference is embracing community and doing this together and not being so individualistic. That we might not have the national will to make some of these changes, but that state and local and international coalitions and communities can continue to make that difference. And I think often about a quote from Bill McKibben. Bill McKibben, who was a leading climate activist, was asked by someone that what can I as an individual do to make a difference? And his response was become less of an individual. Thank you very much.
Yay. Thank you, Alex. Man, appreciate the deep dive. I feel like that was you know, like two college lectures all packed in
Yeah, last time.
there. Appreciate it. Man, yeah, you kind of took us through all of it. I love how at the very end you kind of wrapped us up with some actionable things, and that to me I think is one of the big messages in when it comes to climate change or really any environmental issue is find a couple that resonate with the individual and do something that you feel like there's longevity to, that there's something that you are passionate about, that you're not going to get bored of,
Mhm.
a couple weeks or months down the line, and just keep churning that out, uh,
Yeah, I appreciate that. I will also mention two quick things. One, the National Audubon Society has put together a letter that about 217 local chapters have signed on to the U.S. Senate's Energy and Natural Resources Committee. And Nevada Senator Catherine Cortez Masto is on the Climate Crisis Committee and the Energy and Natural Resources Committee that has been sent that letter to be reviewed. So that's something, if that is your senator, or if your senator is on that committee, whatever state, to look into. And as Alex mentioned I just moved to San Diego. Tomorrow morning, I start orientation for a 1 year master's in climate science and policy at UC San Diego's Scripps Institution of Oceanography. So come back in a year, this presentation might be different.
Mm. Well, thank you, Alex. Appreciate it. And for everyone, we Red Rock Audubon was one of the chapters that signed on to that letter. The letter was it's a sign-on letter from National Audubon, went to the House and then over to the Senate, and then for review, that'll be the Natural Energy and Natural Resources Committee will review that as well. And as Alex mentioned, Senator Cortez Masto is on that. And this year we have been in touch with her and her aides to express, some of our concerns and our positions as they relate to birds, climate change, water in the West. So, if you're looking at this presentation and thinking like, wow, the odds are super stacked against us here, please do know that we as a chapter are probably one of the most active chapters when it comes to actually communicating directly with our elected officials. So, three of our four congressional representatives in the state and both senators are very receptive to what we have to say. The one that is not in Congress is Amade, and he was one of the masterminds behind one of the um, public land sell-offs that never actually took flight just a couple months ago. So he represents other districts in Nevada. So everyone, are there any questions? I know it's probably beyond dinner time, and I want to get through any questions that we have. If not, then you can find this recording if you want to look back at it in a few days on YouTube. I'll look at the main chat before to see. Olivia said, thank you so much for great information. Michael F. said, thank you, Alex. That surely you,
Yeah.
this is a powerful presentation. We need more well-informed voices to make the renewable message louder than that of corporate dinosaurs. He says, thank you so much for your presentation. Morrigan, who's a
Yep.
habitat restoration steward over at one of our river basins in the Mojave. We have just a few, and one of them is the Amargosa River. And so Morrigan says, this is excellent. Appreciate the deep dive into climate change rhetoric. Amy says, thank you. This was really great. Stephen, a student at UNLV, thank you. And Olivia says, I will share the recording. So
Cool.
thank you, Alex. I appreciate it. Doesn't look like there are
Alex.
questions. And you're a neighbor of ours, so come see us sometime and come birding with us. We'll definitely find a way to, bring you into, say, the Henderson Bird Viewing Preserve and invite some folks out. Think about
Awesome.
it.
Thank you so much. Yeah, I appreciate everyone coming out.
Cool. Thanks, everybody. Alex, if you want to stick around just for a moment while people log off,
Oh, yeah.
I'm going to end the recording.